All right, welcome back to IDIS 343. We've built the EOQ, we've added lead time, and we've handled producing the item ourselves at a finite rate. Today we tackle the last big piece of this chapter, quantity discounts. This is where the per unit price stops being a fixed number and starts depending on how much you order. And this is about as real world as inventory math gets. It's exactly the kind of pricing you run into with just about any industrial supplier. Now, up to this point, we assumed the variable cost C was the same no matter how much you bought. But in real life, suppliers offer price discounts to encourage customers to buy larger quantities. Sometimes they might be trying to reduce their own inventory or cutting transportation cost. For example, you might be getting a truck delivery when you buy a pallet of a certain product or 5 pallets of it. So encouraging customers to buy helps them to reduce the transportation cost. There are 2 flavors you'll run into. In an all units discount, the lower price applies to every single unit in the order once you cross a breakpoint. In an incremental discount, the discount applies only to the units above the breakpoint. The all units version is far more common in practice, and that's the one we'll focus on today. Let's look into the example in the textbook, the weighty trash bag company and its large can liners. Their price schedule works like this. Under 500 bags, you pay 30 cents each. From 500 up to 1,000, it's 29 cents. And at 1,000 or more, it drops to 28 cents. The breakpoints then sit at 500 and 1,000. Now here's the quirk that catches everybody. 499 bags would cost you $149.70, but 500 bags cost only $145. You pay less for more. Why on earth would Weighty do that? Well, if you were already eyeing 400 bags, that pricing nudges you to bump up to the breakpoint and grab the discount. Other reasons could be that Weighty may store its bags in lots of 100, and the handling it saves on a clean 500 bag order can more than make up for the lower price. Alright, how do we actually find the best order size? We'll use the textbook setup. Suppose a company buying from Weighty uses trash bags at a steady rate of 600 a year. The fixed cost of placing an order is $8 and holding costs ride on a 20% annual interest rate. And the 3 unit costs straight off the schedule are 30 cents, 29 cents, and 28 cents. We'll label them C0, C1, and C2. Now the first step, and this is really the heart of the method, is to compute an EOQ for each price using H equals I times C at that price. Q0 at 30 cents is the square root of 2 times 8 times 600 over 0.2 times 0.30, which comes out to 400. Q1 at 29 cents gives 406, and Q2 at 28 cents gives 414. Notice they barely move because the price only shifts a penny at a time. Here's the catch: an EOQ only counts if it actually falls inside the price range that produced it. We call that being realizable or feasible. Q0 is 400 and the 30-cent price is valid from 0 up to 500, which means 400 is feasible. But Q1 is 406 and the 29-cent price only kicks in at 500, which makes 406 infeasible. And Q2, 414, would need to be 1,000 or more, also infeasible. Now picture what's happening on the graph. You've got 3 separate cost curves, one for each price, and each one is only valid over its own stretch of order sizes. String together just the valid pieces and you get a single broken discontinuous curve, the one drawn in heavy shading in the figure. And that broken curve is the real cost you actually face. Our whole job is to find the lowest point on it because it jumps down at each breakpoint. The minimum might sit at a smooth bottom of one piece, or it might sit right at one of those price break cliffs. Alright, this slide puts the actual cost function up on screen. The general form is that's purchase plus setup plus holding, and there's one version for each price, G0, G1, and G2. The piecewise rule shown tells you which to use. G0 on 0 up to 500, G1 from 500 up to 1000, and G2 at 1000 and beyond. Now we plug in the three candidates each at its matching price. At Q equals 400, on G0 we get 600 times 0.30 plus 600 times 8 over 400 plus 0.2 times 0.30 times 400 over 2, which lands at $204 even. At Q equals 500, on G1, it works out to $198.10. And that's the value the slide box is in green. At Q equals 1000 on G2, we get $200.80. The winner is 500 bags at $198.10 a year. Now notice the deepest discount, the 28-cent price at 1000, did not win. Chasing the lowest unit price just buried us in holding cost. The middle breakpoint turns out to be the lowest cost option. Now let's test the idea with a practice problem. Suppose you've already computed the three EOQ values for an all-unit schedule, and you get Q0 equals 800, Q1 equals 875, and Q2 equals 925. Part A asks, with breakpoints at 750 and 900, can you pin down the optimal order quantity straight from the graph? And Part B changes those breakpoints to 750 and 950 and asks the same thing. The slide highlights the guiding rule in green, and it's the one to hang on to. The optimal is either the largest feasible EOQ or one of the breakpoints that exceeds it. Here's Part A drawn out with breakpoints at 750 and 900. Look at the picture. There are three thin curves stacked up. G0 on top, then G1 with G2 sitting lowest because the cheapest price always rides along the bottom. The heavy black curve is the one that matters. It traces the top curve until 750, then drops down a level at that breakpoint, rides the middle curve over to 900, then drops again onto the bottom curve. That broken shaded line is your true cost. Now the feasibility check marked right on the slide. Q0 is 800, flagged red, infeasible because the C0 price dies at 750. Q1 at 875 is green, feasible, and Q2 at 925 is green as well. The largest feasible EOQ is 925. And here's what the graph shows you. That heavy curve bottoms out right around 925, sitting on the lowest curve, and there's no breakpoint beyond it to pull you any lower. Hence, the optimal order quantity is 925, no extra arithmetic needed. Now Part B, same EOQ values, but the breakpoints shift to 750 and 950. Watch what changes in the picture. Q2 at 925 now flips to red, infeasible because the bottom price doesn't begin until 950. 925 falls just short of it. Q1 at 875 stays green and feasible, which now makes it the largest feasible EOQ. The heavy curve rides the middle curve down to a trough around 875. Then at 950, it drops onto the bottom curve. And here's the catch the graph throws at you. That drop at 950 lands on a competing point. And by eye, you genuinely cannot tell whether it sits above or below the 875 trough, unless you draw everything to the scale. Unlike Part A, the picture alone won't crown a winner. The extra step is to compute the average annual cost at both 875 and 950 and take whichever comes out cheaper. And that's the real lesson here. Sometimes the graph settles it like in Part A, and sometimes you've got to crunch the breakpoint like in Part B. Alright, that completes the all units discount model and with it Chapter 3. Thanks and gig 'em.